Welcome to Ask and Learn.
On an island after n months. And so first, if an is months in the future, the first thing is that any rabbits that are just a month old are not reproducing yet, right? So those rabbits will be the exact same number in this month as they were last month. And so that gives us an minus 1 is staying the same. Then for rabbits that are 2 months old, in this case, these are each reproducing 2 pairs of rabbits. So we need to take the number of rabbits that we have in the previous month, subtract the number of ones that we had 2 months ago, because that will tell us all the ones that are 2 months old. And then these are all reproducing, right? So we're going to multiply that by 2. And then the other condition here is that rabbits that are older than 2 months are having 6 babies, right? And so in this case, the rabbits that were born 2 months ago or n minus 2 earlier each had 6 pairs of babies. So this is going to be 6 times an minus 2. Okay, and so if you combine all this and simplify it a little bit, combining the like terms, so we have an minus 1 plus 2an minus 1 for 3 times an minus 1. And then we're going to add the 6an minus 2, but minus the 2an minus 2, right? So it'll give us 4an minus 2. Okay, and then this is our recurrence relation for the bunnies. And so that would be part A. And so now we want to solve it. So part B is to solve it after 1 pair is left on the island. So that would mean a naught is equal to 1. And then we need to think to get our other initial conditions. So at 1 month, the 1-month-old pair of rabbits would have 2 new pairs of rabbits. So a1 would need to be equal to 3. Okay, and then our recurrence relation I will rewrite here is equal to 3 times an minus 1 plus 4an minus 2. So to solve this, we want to do the roots characteristic equation where we replace an by r squared, an minus 1 by r, and an minus 2 by 1. And so we would rewrite that as r squared minus 3r minus 4 is equal to 0. Factor and get r minus 4 times r plus 1 is equal to 0. So r is equal to 4 and negative 1. So this means that our homogeneous solution is equal to alpha 1 times 4 to the power of n plus alpha 2 times negative 1 to the power of n. And of course, in this instance, it's actually just our entire solution because there was no other components, functions of n written there. And so we can use our initial conditions to solve here. So we know that one is going to be equal to alpha 1 plus alpha 2, and that 3 is equal to 4 times alpha 1 minus alpha 2. So if we add these together, we end up with 4/5 is equal to alpha 1. And then if we put the 4/5 into this first equation, we know that 1/5 is going to be equal to alpha 2. So I just added these two together. The alpha 2 canceled out. And so we had 5 alpha 1 is equal to 4 divided by 5 on each side. Okay, so then we can put these into our equation here at the top. Apologize, not that equation. Of course, we want to put it into this equation here, replacing our alphas. So what we end up with is that an is equal to 4/5 times 4 to the n plus 1/5 times negative 1 to the power of n. And of course, these are both over 5, so we could simplify it a little bit as 4 to the n plus 1 plus negative 1 to the n over 5.